I tell you what. It takes a minute to get on to you guys and girls. How y'all doing today? Welcome to Spindle TV. If you're new here, my name is Laney Shaughnessy. I'll be your host for the evening. Sorry it took so long. I'm running behind schedule because for some reason it would not let me connect to you guys tonight. I could talk to you in the chat, but it would not let me connect. So, let's just jump right into it. Welcome everyone. How are y'all doing? Sorry we did not have a class last night. We had major storms and fluctuating electricity and internet and things like that. Big, massive hail. I mean, from the size of golf balls to baseballs was falling on all over the place. But we made it through unscathed. Few trees down in the front of the property, but nothing major. So here we are tonight. All right. Tonight we are going to work on a project that I've been wanting to make for myself. We're going to make a sushi tray, and we're going to talk about different designs, different options, you know, whether it be a party tray, maybe a sushi tray for two, you know, like for a couple's night or something like that, or just a single sushi trays, right? We're going to look at the three different sizes and stuff, and we're going to look at the options and everything. This project will involve being a two-sided project, and it will have some inlay work to it. So the part that's inlaid could either be carved and epoxy filled. It could be laser engraved if someone wants the laser. I'm going to do a V-carve inlay. So we're going to talk about that tonight. And then we're going to talk about the chamfer tool and some other tools, right? We're going to get into this and everything. So hopefully you enjoy tonight's class. And with that being said, let's jump on into it. We are going to, let's see here, start off by switching over to, on channel 2. Let's get me down in the bottom. Let's move me down here. Let's get the camera to take the TV off the screen. There we go. Wonderful, wonderful, wonderful. Hopefully you can hear me. Hopefully everybody can hear me very well. And I'm not too loud or anything like that. And we can get into this. Okay. So, we are going to, the one project we're going to work on is going to be a single serving type of tray for an individual, right? So, an individual and things. And we're also going to look at, like I said, a tray for two, and then even like a party tray that could be, you know, like, you know, up to 4 people or something like that, you know, a party platter, whatever you want to call it. Now, there might be some buffering tonight. We still have, the weather's not the greatest, and we're supposed to have storms starting this evening again. So if I get because of the internet, I can see the data rate traveling over to the web. All right, so we're going to have buffering tonight, guys and girls. I do not know how well it's going to go. My data rate is low because the internet signal, they're still working on internet in town and everything. So let's see how we're going to try to get through, and hopefully things will pick up. And that's about the best I can offer. So I might sound distorted. It might look distorted. It may buffer on you. It has nothing to do with me. I can't control Mother Nature and the cable company, right? So they're working on it. We got major storms, and they're supposed to start again tonight. So hopefully we can get through with minimal issue. Okay. All right. So we are going to be focusing on, and Big Daddy Fish, thanks for those 2 projects you emailed over. I didn't get a chance to reply and say thank you. Those 2 projects you shared with me, those are pretty cool. I appreciate that. Okay. We are going to be working on a single tray tonight. And one of the things, this could be an item that would be a popular selling item that could be easy to make from scrap wood for the most part. And it could be something that's low cost that sells, high yield. I mean, most sushi trays and everything, they're running around $145 to $250. You can get, cheaper as well too, but on your Etsy pages and everything, if I were to look at wood sushi tray, and if I were to go to images and click on just one and drag it over onto the screen here. This is a party type platter for 4, could feed up to 4, around $295 on Etsy, right? A single, just a basic plain sushi board that's just a board with a groove cut in it pretty much. You're looking $59, $60, right? So these, even at low ends like Amazon, right? $11.79. It's just a piece of pine with some legs on it. That's it, right? Nothing fancy or anything like that. But they can get fancy and they can get, decorative and stuff and all. And but they can also be expensive. They can, they could yield a good markup for you in things like that. So that being said, don't sleep on this project. This project could be a good one to add to your repertoire. All right, now there are 2 things that I'm going to recommend that you do. There's 2 things that I'm going to recommend that you do, and that would be on Amazon. Look at chopsticks, whether they be wood, metal, what have you, reusable, disposable, whatever the case may be. I probably, if I was selling a single serving sushi tray or even a double tray or a party tray, I would sell it with a set, either a single set of chopsticks, a dual set of chopsticks, or up to 4 sets, right? And depending on, bamboo sets are really nice and everything. There's all kinds of decorative ones as well too, to where they could be added into the cost of this item that you're selling, to make it a little bit more desirable. So it's a sushi tray with chopsticks and everything, and there's all kinds of different designs, and they can range, right? And the prices will, the prices for the sets, depending on how fancy you get or how basic you are, that just adds into your cost, right? So that's just, part of the cost. You can add a little bit of a markup to it, depending on, which way you go, and all that too, because you're reselling it, right? So chopsticks is one of the things that sets, and again, you could go disposable, right? They get their own chopsticks, but here's a disposable set to start you off, kind of thing. Or you could go with a nice set that's paired with that tray, right? Aside from that, another thing that I would probably have to go with my sushi tray would be a soy sauce bowl, or a sauce dish or what have you. Now I'm going to create pockets. You'll see in the design that we're about to jump to in a minute, but there'll be a place for like ginger or for wasabi and stuff like that we're going to carve little, kind of like a little recess for those kind of things and stuff. But the sauces, I could carve just a pocket to pour the sauce in right onto the tray, but I'd like to kind of keep it somewhat clean, right, where there's not sauces soaking in, even to the finish and stuff. So small sauce trays, like these Asian small porcelain bowls, 1.2 ounce bowls. They're roughly about 2 inches in diameter at the opening at the mouth and all, but $37 for a set of 50, so they're about 75 cents a piece. So one tray, one bowl, that 75 cents would be again added to it. So you'd have a tray with a set of chopsticks and a bowl, right? And that would be your little kit that you sell for whatever. That little bowl costs you 75 cents. Your chopsticks cost you whatever they did. And then, you know, whatever scrap wood and finish and all that stuff and time you put into it there. So very low cost to make this item could yield a very high profit, right? So that being said, the set that I would go with is this set that's right here first on the screen. It's the 50-piece soy sauce dish, the ceramic white bowl. It's a 1.2 ounce Asian small porcelain bowl for sauces and stuff. And this bowl, if we look at it and everything, let's get over here to the kind of the dimensions. At the wide diameter, you're about 2.8 inches, you know, 2 3/4 inches in diameter. The small diameter, I'm not quite sure what the small diameter is, but it's probably going to be around 1.8 inches, that small area and stuff, but we'll accommodate for that accordingly and everything. We're going to have a little recess for this dish this size to sit into. And but it's a perfect size for, you know, dips and sauces and seasonings and things like that. So this particular item is, I just typed in small soy sauce bowl, and it's kind of the first item that pops up. It's the 50-piece soy dish tray. It's the Memoro brand, and it's got a good 4.2 rating and stuff, but that's probably what I would go with because it's about 75 cents a piece, right? Okay, so chopsticks. Again, there's all kinds of different, you know, here's a 10 pairs, nice wood chopsticks, and they have bamboo too. Bamboo's really good. It's good for the environment, all that good stuff. But 10 pairs for $8.99. So again, you're less than $1 a pair, right? That kind of thing. So, you know, you can search and see, you know, what is, what's good for you. Okay. That being said, now there's going to be three sizes that, that we have for our trays that I'm going to do for my tray. So my individual tray, mark it down, write it down, whatever you have to do. But my individual tray is going to be around 11 inches long, 7 inches wide, and I'm either going to be at 3/4 inch thick or I'm going to be at 1.25 inches. Okay, I'm going to go 5/4. Like if I buy a really nice piece of wood or you know, lumber, hardwood or something from my lumber yard or my sawyer that sells Appalachian Southern hardwoods and some exotics and things, I'll probably end up getting, you know, close to a 1-inch board rough sawn that'll mill down to about 3/4 and stuff, or I'll get a 5/4 board. A little bit thicker than 5/4 that'll mill down and smooth out about, you know, 1.25 inches thick and stuff like that. You could go thicker, right? But, you know, too massive, it doesn't need to be too big, right? And if you don't have that kind of wood, you can always glue 2 3/4 inch boards together, right? To create a thicker board, that type of thing. So, hey, Big Daddy Fish, man, thank you for the super chat. Ladies and gentlemen, if you look at the screen on the chat, that pink banner from Big Daddy Fish, that is called a super chat. It's a way to help out. They're down. There's a little $sign under where you type in the chat. If you want to, you know, support the channel and anything like that, you can do small donations and everything. Big Daddy Fish, man, you just you bought some lumber for me there. All right, I appreciate that. Now, in this case, my single serving tray, it really depends on the setup and stuff, but I'm either going to be at 3/4 or 1.25 inches. All of my trays, the dual person 2 people tray and the party tray up to 4 people, I like 1.25 inch thickness. I like to, if I don't have that type of lumber laying around, I'll glue 2 3/4 inch boards together because I'm going to be surfacing on both sides and everything to get a nice flat surface and all that stuff. So I'll bring it down to 1.25 inches when it's all said and done, right? And things like that and all. So no, thank you, Big Daddy Fish. But I'll bring it down to you know, 1.25 inches, and that's kind of where I like to be. Just let's get it there. That's what we're going to work with tonight, is an 1.25 inch thick piece of material, and let's get started kind of with that. So if we look at this particular job setup, here's my 3 sizes of my board. So my single serving board is 11 by 7 by, and you can go 7 1/4, like a 1 by 8 type of thing, but I go 7 inches, 11 by 7 by 1 1/4 inch thick. That's my single serving board. Now I'm going to create another sheet, sheet 2. Sheet 2 is going to be my, sushi for 2, right? Sushi for 2 board, right? And that board, if we go into edit and set that one up, that board is going to be 18 inches in length by 7. I'm going to stick with the 7 on that one. 18 by 7 by 1 1/4 thick. So that'll be my sushi for 2. And then my third, which I would kind of consider the party platter, right? Will, sorry about that. Let me turn the do not disturb on for the class. There we go. We'll call this sushi for 4 because it could up to 4 people, right? Or a party platter, whatever you want to call it. I'm just going to call it sushi for 4, right? Now that one is going to be a little bit bigger and a little bit wider to accommodate some more food and all that stuff and everything. And the sushi for 4 platter is going to be, I'm going to go 20 to 21 inches. I'll go 20 on this. And I'm definitely going to go 9 1/4, like almost like a 1 by 10 type of thing. So 9 1/4. And again, 1 1/4 thickness. Now, for all 3 of the projects we're going to design and work with the one, the single serving for tonight. And then you can use your imagination and stuff for the other 2. And we'll talk about the other 2 because I'll talk about like how the layout and stuff and everything. Because we got a lot to cover with the inlays and all that stuff. But for all of these, I'm going to be referencing and zeroing out on the material surface and starting in the bottom left corner of the material. So that's kind of where my setup is. So that is going to be my 3 setups, my 3 boards. Okay. So my single serve, my sushi for 2, and sushi for 4, right? So that's kind of where we're at. Now, let's go back to the sheet 1, and let me I'll go sushi. We'll stick with the theme here for 1, right? Now, first things first is I am going to be doing a 2-sided job. And on this 2-sided job, I am going to have my alignment pinholes, right? Now, because of that, because of the flipping and everything and the alignment holes that I'm going to be using, my 11 inches is going to remain the same. The 11 inches is going to remain the same, but I'm going to go a little bit wider on the board so I can have a place for my alignment holes. Now, one of the things that I was thinking about, and I'll probably talk about this more. I'll probably talk about this more in another class on 2-sided projects and stuff. Hey, Joe Scotcha, how you doing? I'll probably talk about this more in another class, but on 2-sided jobs. But when we are doing a 2-sided job, and if we're using the alignment pin method, meaning that we're going to drill 2 holes in the top of our project board, and then we're going to end up drilling 2 kind of corresponding holes that are a little opposite depending on which way we flip our board. We're going to be drilling 2 holes in our wasteboard to accommodate that 2-sided project. Now, if I don't want to be drilling holes in my wasteboard to accommodate this 2-sided project and everything, then I might create a jig for myself where my jig will be probably a piece of plywood or something. It could be MDF, but it's going to be thin, relatively thin. It doesn't need to be too thick. And it's going to be able to accommodate up to, in my case, 21 inches, right? And, 12 inches on the width kind of thing. But I'm going to have, based on these different size boards and everything, I might create a grid where I have alignment holes. And I can use these hole placements as a template. I can save them when I draw up this design to make these holes and everything in this wasteboard piece, in this piece. I can use the design to help me when I flip the board over. I can use any two holes that correspond with the current X and Y, but I can use the two holes for that size board that are already kind of made up in this template, that I don't have to drill a bunch of holes and keep beating up my wasteboard kind of thing. For tonight, we're going to just lay out the holes and everything and assume that, you know, we're going to do it in the wasteboard and all. But I think the next class, we're going to focus a little bit on setting up a jig for a two-sided project that it can accommodate. And I'm going to draw that up and come up with that concept and idea that's going to be pretty much a staple in the shop for two-sided projects for a jig to throw up on the table and stuff. I think we're going to create that in the next class. So we'll focus on that. But tonight, okay. Okay, ladies and gentlemen, I do not know if I am back on or not. Okay, I apologize. We have lost, we temporarily lost internet, the facility did, and I'm not sure how long it was out. All I saw was buffering, and I thought, you know, it was just a no connection, but then I just noticed that we had no internet at all. So hopefully we are back, and I am back. So let's try this again. What I was saying before we were disconnected, and I have to try to remember what I was saying before we were disconnected, but I'm either going to be making my project a little longer or a little wider to accommodate the flipping of the board and the setup, because it is a two-sided job. But when it's all said and done, no matter which way, if I go wider or longer, I'm going to be cutting that excess off. My finished piece for the single-sided or single-serving sushi tray is going to be 11 by 7. So what I'm going to do in my setup here is I'm going to let's add some length to it. We'll just add some length to it. So I'm going to add 1 inch on both ends. So instead of 11, I'm going to make it 13 inches here. And we'll go there. Okay. Now, I don't know how much you guys and girls heard. Let me know in the chat if you heard me talk about, you know, maybe next week's class we're going to talk about two-sided jobs and maybe setting up a jig to accommodate alignment pins for different size materials. Different size materials. So maybe we'll do that. All right. So tonight I'm going to draw my rectangle just to show me my work area, right? So 11 by 7. And we're going to go half the width divided by 2 equals up here, and height, h, divided by 2 equals. That'll give me my center point. So I can create my layout area. And hey, Brooks, thank you. I'm glad you agree. All right, so this is my layout area. Now, we're going to start off with the alignment holes. Let's get those in there. I'm going to use 1/4-inch dowels. Now, I use 1/4-inch steel pins. They're a 1/2 inch long. I bought some, 1/4-inch rod, cut off, a few 1/2 inch pieces and everything, and sanded and rounded off the edges to smooth the metal, and also it wasn't sharp, and also it went into my holes very easily without damaging anything. All that wonderful jazz. But I have 2 alignment pins that I use for my 2-sided projects, and they're 1/2 inch in length, 1/4 inch in diameter. Now, when I'm doing my alignment holes in my project board, my depth of my alignment holes is 3/8 of an inch. In my waste board, the depth for the alignment holes is 1/4 of an inch. That little 1/8 of an inch extra is placed so I don't bottom out, one of my 1/2 inch pin and everything. So in this case, I'm going to throw in 2 alignment holes here. Now, here's the thing, just so you kind of get the concept and all. When this jig is created to accommodate different sizes of material and everything, we would be able to open up a template. We would be able to open up the template or import the template into this design, let's say, and we'd be able to line up where our X and Y is going to be and where our holes would line up, and we could use the holes from the template so they would match for the, the holes in the design, right? For when we flip and all on the jig and everything. So we'll create that in this coming up week, and I think that'll be a great project. All right, here we go. So I'm just for right now just random positioning on these holes. This is random here, and it doesn't matter where they are. But I'm going to go ahead, and my job setup on my sheet 1. The one most important thing is this is going to be a 2-sided job. So on my setup here, it's going to be a 2-sided job, and I'm going to be flipping along the y-axis. I'm going to be flipping along the y-axis on this job. Okay, and I will be referencing off the material surface. I'll be referencing off the material surface for both of those jobs and everything. So once again, we're all set up here. Good. Okay, so I'm going to take my 2 alignment holes and my work area here, and I'm going to copy it to the other side. Copy to the other side. Okay, copy to the other side. So that way I have my, side 1 and my side 2. Now, when it comes to the carving, the bottom side of this sushi bowl, I'm going to have these long chamfers. I'm going to have a short chamfer on the top and bottom, and I'm going to have long chamfers on the end. So if I did the bottom side first, right? If I did the bottom side first, then it would be kind of somewhat unstable when I flip it over to do the top side. And the top side's got all the cool stuff and everything. So I'm going to design the bottom side first, right? I'm going to design that. I'm going to design it here right now in the class up front. But we're going to actually be carving the top side first, then flipping it over and carving the bottom side last, like normal and everything, okay? But for now, I'm going to be getting the bottom side out of the way, all the chamfers and stuff, because the majority of the class is going to be focusing on the V-carve inlay and all that, okay? So, not to confuse you, this is going to be, I'm on the bottom side here. You can see the word bottom. This is where we're going to start. Now, for the bottom side, I'm going to take my work area here and I'm going to take my vector, and let's get out of the sheet tab for a moment. I'm going to take my vector here, and I'm going to go into node editing mode, and I'm going to cut the vector on all four corners. Okay. I'm going to cut the vector on all four corners here. And because I'm going to use the two side lines for my longer chamfers and the top and bottom line for my shorter chamfers. I'm not going to, have just a rectangle and chamfer all the way around kind of thing. So what I want to do now is I want a chamfer, like when this thing is sitting on the table, there's going to be legs. You'll see that too. And let me show you a reference image because a lot of you are visual. Let's see here. Bear with me a second. A lot of you are visual folks, and you like being able to see, kind of have an idea of where things are leading to and stuff. If you look at, like if you typed in wood sushi tray, wood sushi platter, and things like that online, you would notice that a lot of these trays and everything have kind of these spanned feet on them. There's these kind of legs. They could be individual feet, like the party tray has these round aluminum, type individual feet, or they're, just a block kind of that create, just the leg. It's kind of a riser, if you will, that takes and lifts the tray up off of the table, kind of thing. And instead of it sitting flat, in case the surface isn't flat or whatever, having the two legs makes it a little bit easier to kind of balance on instead of something being wobbly, without, any support. We're able to kind of span that and everything. And there's all types of different designs and things, on how those feet are created and everything. But I'll show you my take on it and everything. So what we're going to do is on my chamfer, I'm going to have the chamfer on the two sides. I'm going to select here and here. And I'm going to be using a 120 degree V-bit. I want to use a 120 degree V-bit, and I want to create kind of a 60 degree long chamfer. And in my case, the chamfer is going to be about 1.25 inches. I want to go 1.25 inches. Yeah, 1.25 inches is good. And I'm going to go 1.25 inches. And that means based on that bit, my 1.25 inch width that I want to do, it's going to be a cut depth from the bottom up, right? So the depth from the bottom to where it finishes, where that angle finishes, it's going to be about 3/4 of an inch on that 1.25 inch, right? So that's going to leave me, a 1/2 inch of kind of like a lip, if you will. If I want it thinner, I go deeper, that kind of thing. But I can change my width, and it's going to automatically change my depth based on what I want to do. But the most important thing about a chamfer, no matter what you're doing, is these arrows, okay? When you're doing a chamfer toolpath, if you're doing a nice little chamfer on your border, if you're doing, any kind of chamfer, the arrows always point to the deepest part of the cut, okay? And it's all going to be based on the chamfer type in the box here, okay, where it says chamfer type. There's an inside or an outside chamfer. There's a slope upwards or a slope downwards option as well. Now, inside means that the cut's going to start on the inside, and it's going to work its way outside. In my case, it's working towards the line, right? Towards the end of my board. And the cut depth, I'm getting deeper, right? From the bottom, I'm starting like 0, right? And I'm cutting down. I'm getting deeper as I'm getting towards the outer edge of my board. That's what this arrow is indicating. So this chamfer type is an inside cut sloping upwards, okay? Inside cut sloping upwards, meaning from the deepest part of the cut outwards, it's going to be sloping upward. All right, in our case, it's carving downward, but the slope is sloping upward. I know the wording is confusing, but that's how they made it and all that stuff. Now, if I were to choose an outside option, that means that the cut's starting outside and working its way towards the line in that direction. That's not the option I want. That's not what we're doing, right? We're always going to be cutting towards the line in this case, and what we're doing here. And we want the deepest part to be at the end of the cut, the end of the line. Because remember that board, this waist is getting cut off at the end. This waist right here is getting cut off. So it's very important on our lines where our start point is, because if I were to change the start point, it changes what that option is, right? If I were to change the start point of the line, it changes what that option is and everything. So it's very important where our start points are to make sure that our cuts, are cutting in the correct direction. That's very important with a chamfer cut. Remember, the point of the arrow points to the deepest part of the cut. So if I'm on top of my board, we'll use my cell phone as an example here. Well, here, we'll use this as an example. If I'm on top of my board and I'm cutting my chamfer outward, right? The deepest part of the cut is going to be out here, right? Imagine this straight across. This tapers down. So this is the deepest part of the cut. That's what the arrow is pointing to, okay? All right. Let's go ahead and let's calculate. We're going to start at 0, use a 120 degree V-bit in my case. I want my cut width. I set the cut width to 1 1/4 inches. I want it to be 1 1/4 inches from the end of my board inward, 1 1/4 inches. That's what I want. And based on that angle of that V-bit, that 60 degree angle, 120 degree included angle, 60 degree half angle, based on that 60 degree angle, I'm going to be cutting 0.7217 inches down, so close to 3/4 inches deep, into this cut. Now I'm going to calculate that cut. And I'm also going to, just for preview purposes only, I'm going to create a profile cut to cut the ends of these boards off, just so you can see like when the ends are cut off. I'm going to cut a profile cut. Let's see here. Profile toolpath. I'm going to cut all the way through the material so I can cut those ends off just for preview purposes only. I'll use a 1/4 inch end mill to do that. Cutting on the outside of the line. Click calculate. And what's important to me is when I look at my 2D view here, let's get out of solid view here. I want to make sure that I'm cutting on the correct side of the line, right? Outside of the line here, outside of the line there, that kind of thing. All right, so let's cut off the ends of our board. The waist, we'll do that first. Let's cut that off and everything. We can turn the tool off. We don't need to see the tool there. We'll cut off that waist. Wonderful. Let's get rid of that. Now, what the chamfer is going to do is it's going to take small steps, and those steps are going to get deeper and deeper as they go. My waist came back. Those steps are going to get deeper and deeper as they go and everything. And so, let me get rid of the waist. When this is flipped over, this is the top of the board, I'm going to have this 60 degree angle kind of coming upward on the two ends. Now, if I wanted my ends to be a little bit thinner for decorative purposes or whatever, or rounded, I can round them over by hand and all that stuff and everything. But if I wanted them to be a little bit thinner or something, then I would make my cut depth deeper, which would make it longer, right? So I just have to figure out what I want. And for my case, that 1/2 inch end, the 1/2 inch end is fine for this. Okay, so that's what the two ends are going to look like. All right, now my top and bottom line, I'm going to do a chamfer on that. Now, this is also going to start at 0. It's also going to be a 60-degree V-bit or 120-degree V-bit, 60-degree half angle. But I only want the cut to be 3/4 of an inch. And notice where my lines are. They're outside. Here are correct. Inside, pointing towards the line. That arrow is pointing towards the line. I need this to do the same thing. So that means I need to go into node editing. And I need to switch my start point. Make this the start point to reverse those arrows. Get them on the inside. Okay? So I went over to this node. I right-clicked on it, and I made it the start point. That green node. All right. So once again, select this and this. I'm going to be, with that 3/4 inch distance that I've chosen for myself, that's going to be a cut depth of about 0.433, so about 7/16 of an inch and everything. So I'm going to calculate that. And let's preview that toolpath. Okay, let's get rid of the waste so it doesn't confuse you. Double click on the waste, gets rid of it, right? If it's not connected with tabs. Now that's going to be the bottom of my sushi tray. So I'm going to have this nice little chamfer on the sides and these longer chamfers on the ends. And that's going to be the design of my tray for the bottom part as far as the chamfer cuts that I want. Now, if I put a check mark in both of these chamfers here, and I go from wireframe to solid view. Hey, Pablo. Hey, Pablo. Everybody missed you. All right, but here and here, if I go from wireframe to solid view, this icon at the top of the screen, that'll show me where my cuts are going to be, right? The material that's going to get removed. Okay, so that's where the material is going to be removed. Now, that's important for me because I'm about to draw two rectangles. These rectangles are going to be, this rectangle is going to be an 8 inches long, 1 inch wide. And I'm going to bring it over here and center it up and down. I'm going to use the alignment tool to align up and down on the material. And I'm going to bring this over just a smidge. I'm going to move it over against my purple line where my chamfer starts, right? That's where my chamfer starts and everything. I don't want to be right up against where my chamfer starts, so I'm going to move to the left a 1/4 of an inch. Okay. And then I'm going to take that object and I'm going to mirror that. Flip about job center, mirror horizontally to the other side. And that's going to be the vectors for the slight recess for my leg pieces to fit into. Now my leg pieces, I'm going to draw out so you can understand what I'm about to do here. But my leg pieces are going to recess into the bottom of my board here by 1/8 of an inch. I'm going to create a pocket cut. An 1/8 inch deep using a 1/4 inch end mill. And this is going to be my foot pockets, plural, right? Or feet pocket, right? One of the two. Okay, so let's do that. And preview that visible toolpath. Okay. And so what you'll see here, ignore the waist. Remember, the waist keeps coming back, right? Every time we do a preview, it'll pop back and everything. But now let's zoom in on this. Everybody, here, let me close this so we can get a full view there. There we go. All right. So now we have our recess and everything where our pocket's going to fit in. Now, let's do some talking here, okay? Let's do some talking. Let's do some drawing and everything. I'm going to draw a side view or an end view for you, okay? So you can kind of get the idea of what's about to go down here, all right? Our project is 7 inches wide and 1.25 inches thick, okay? And on that, we have a chamfer. Bear with me just a second. Relative guide over 3/4 inch. Create. Let me drag this over here. Relative guide. Right click on your guidelines to get your properties box. I want to go negative left, negative 3/4 inch. Create that. Now, I have a chamfer, starting at this 3/4 inches back, coming up that 60 degrees. It's coming down, sorry, it's a 60-degree angle, but it's coming down 0.433 inches in depth. So 0.433, let's see how well I can do my, here, let's do this. Undo, 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 undo. Let's try this again. I'm going to take my guideline down here. It'll help me out with layout. I love layout lines. Right click, and we're going to create a relative guide up, positive 0.433 inches. Now, where did that number come from and all? If we look at our chamfer, right? It's here, the cut depth of that chamfer, right? 3/4 inches back, 0.433 is the cut depth. All right, and so I can now take my line and just connect the dots, right? From there to there. Cool beans. Now I'm going to go ahead and take that and mirror it to the other side of this. But I can't just flip it about job center because I'm not at my job center. Here's my job, right? This is just out in the middle of no man's land for right now. So what I want to do is I'm going to draw a line down the center of my board here that represents my center, because that way I can mirror this selected line. I can select this center line here, and in the mirror tool I can just flip it about the line. I might flip it over, and then I'm going to use my scissors to cut that away. Okie dokie, okie dokie. All right, now, not counting the chamfer coming up and everything. Remember, if we wanted to be kind of visually, right, visual type of thing, there would be a line running across here, space bar, and if I move that line down a 1/2 inch, move down negative number 0.5. You could imagine that, back here somewhere coming up to this angle would be that chamfer coming up, right? But I don't want that to confuse you, so I don't want that line in the drawing. I just want to be, we're looking at the end. I want you to see this side profile. Now, 1/8 inch up here, my foot piece is going to be recessed into there, okay? And my foot piece is going to be, 1 inch wide. Okay, 1 inch wide. And the thickness, the height and all, when it's recessed, I wanted 1 inch off the floor. We're going to go 1 1/8 inches. Do I want it 1 inch? Bear with me a second. No, I'm so sorry. What was I thinking? I wanted 1/2 inch off the table. I want, when the bottom of the foot, I want 1/2 inch off the table. I got to count the 1/8 inch that it's recessing and all, so that's going to be 5/8. And what's going to happen is, let me draw this rectangle here. This rectangle is going to be 8 inches long. 8 inches long. Let me get my size tool open. Thank you very much. That's not the size tool. Let's try that again. It's going to be 8 inches long. It's going to be 1 1/8 inches tall. Okay. I did it again. It's not 1 1/8 inches tall. It's 5/8 of an inch tall. 0.625. Sorry, guys and girls. All right. Now, and let's get it centered with this. So if I select this rectangle first, and I select this rectangle last, then I can align left to right to that last item selected. And let me turn the guidelines off so you're not confused with that. Let's get this. I'm going to snap it up to the bottom here. And then I'm going to move it. I'm going to move it up 1/8 of an inch. Move positive 0.125. Okay. Now, this piece of material here, okay, my piece of material and all that I'm going to be cutting out and everything has to be able to come up the line and also up to here. So what I'm going to do is I'm going to go into node editing mode, and I'm going to insert a point right here. And I'm going to insert a point right here. And I'm going to take these 2 nodes on the end. Let me try that again. My mouse is being goofy. Hold that shift key down. I'm going to take those 2 nodes at the end. I'm going to hit the up arrow key and I'm going to move them up. Right? Now, don't have my line perfect just yet and all that stuff. We'll get it perfect here in just a moment. But what I'm going to do first is I'm going to insert a point. And I'm just going to grab that point right there. And I'm going to drag it and snap it to the end there. Okay? And I'll make sure that this one is snapped here. And then I'm going to make sure I'm going to add another point here. And I'm going to drag this up here. And I need this to be straight across. Like that. Okay? I'm going to do the same thing here. I'm going to insert a point. And I'm going to drag the point and snap it to that corner. Make sure that this point is on this, where it belongs here. I'm going to insert another point, and I'm just going to drag it over to the line and drag it up until it's in alignment with this. Okay? Now, if I were to move this part down now, you would kind of see the feet. There's going to be 2 feet that are cut out to this shape. Yeah, it's not going to be 1 inch off the table, 1/2 inch off the table. That's going to be the shape, but I'm not finished with that shape yet and everything. I need it to be, perfectly balanced and everything. So what that means by perfectly balanced, let me move it up 1/8 of an inch. Move up 0.125. Okay. I need to, let me get it aligned to the center. Oh, you goofball. All right. Now, let me do some fixing real quick here. The distance, I need to, this distance here, I have a 7-inch piece, 8-inch leg. I want a 1/2 inch on both sides. Okay, I want a 1/2 inch on both sides. So that's here, because I'm going to be cutting off some of that waste here in a second. So what I want to make sure of is that, let me get out of this tool. When I'm here, I want to make sure that I have a 1/2 inch from the outside. Okay. So in node editing, I'm going to take these two nodes and I'm going to drag them out to this alignment. Okay, that's a 1/2 inch distance right there. Now, same thing over here. I'm going to take this guideline and I'm going to make sure that I have a 1/2 inch going in the other direction, negative number to the left. And I'm going to take these two nodes on the end and I'm going to drag them to here. Now, with my part laid out, I don't want a 1/2 inch up here. I want, because we're going to cut this off at, but we're going to cut this off at an angle, and that angle, I'd like to go maybe 11 degrees. So the line, I'm going to find my center point here, 1/4 inch. And I want to, you know, if I'm at 90 here, I want to move in 11 degrees. Okay, so that's 79. 79, right there. Space bar. I'm going to take that and match it up over here. So let me find my center again. I'm going to select this, select my center line, and I'm going to flip it, mirror it about that line. And I'm going to take my scissors and trim those two. And the vector that I've just created here is the vector for my foot cutout, my parts. Okay, so I'm going to have a let me snap to there and then move it up 0.125. I don't know why I cannot. I can never hit center for some reason. Align left to right. There we go. Let me trim off because you won't see this. Let me take the scissors and trim that away. So that's what my tray is going to look like from a side view. It's going to have these slight angled legs that come across the bottom. It's going to be a 1/2 inch up. It's going to come out and it's going to go past my ends by 1/4 inch. It's going to have a 79 degree or 11 degree angle cut and everything. So again, to visualize that if we were to grab these examples of these sushi trays and everything, let's take, give me a bigger one. So, well, let me find a larger photo. There we go. All right, So what we're going to have is we're going to have this foot come out, and it's not going to be tapered like this is or anything like that, but it's going to be 1 inch wide, but it's going to have a taper coming down the edge just to give it a little bit of style and everything, and then across the bottom and out the other side. So that's what our leg is going to look like. Whatever species and everything that you use, it's up to you. But that's what we're going for. All right. So that is going to be one of our vector that we're going to use. We're going to take that vector and we'll use that. It'll be on a different sheet to cut out our feet for this single tray. And we'll go there. Okay. Now, I'm going to move this to the other side. Now I'm going to flip over to the other side. Okay. And now we're going to start the real important stuff, the layout of the top of this thing. So we have our, let me see if everything is laid out. All right, good. On the top, I am going to have a place for our bowl and a place for 2 pockets for whatever you want it to be. I mean, you could have, it could be for ginger strips, wasabi, really anything. But I'm going to have a pocket area here. This pocket is going to be 2.5 inches wide, and we're going to go 1.5 on its height. And from my end and from the top, we'll go from the end of the edge, I want to be in 3/4 of an inch and down 3/4 of an inch. So I'm going to use my move tool, and I'm going to move relative over 0.75 and down -0.75 to move to that location there. Okay. I'm going to take that object and mirror it to the other side. I'm going to create in the center an area for my soy sauce bowl or what have you. Now that soy sauce bowl that I picked out was 2.8 inches, almost that's a little over 2 3/4 inches diameter at the top, but it tapers down to a smaller diameter. Now we don't have that smaller diameter. It doesn't. There's nothing. It was nothing in the description that gave that smaller diameter. The only thing to do would be order them in and measure it, right? But I'm going to be creating this pocket, slightly deep and everything, so it's going to be coming up to that 2.8 inches. So as long as I'm 2 inches, 2.25, I'll be good. And it's just a place for that bowl to sit. It doesn't have to be a tight fit or snug fit or any of that stuff. Just a place for it to, sit into. So on the case of this here, I'm going to go with a 2-inch diameter. And I'm going to have it centered left to right on the board. And that's going to be the pocket for my sushi or soy sauce bowl. And then I'm going to have a place for my chopsticks to rest. So we're going to go here. And this is going to have a height of 1.25 inches. And it's going to have a width of 3/8 of an inch, 0.375. And I want this to be where it is fine here on this part, but I want it to be up at least a ½ inch away from the edge here. So I'm going to move it up 0.5 inches. Okay. This is going to be a pocket. We are going to have a separate piece for the chopsticks. The chopsticks are going to rest, and the part that goes in your mouth are going to sit on this piece. This piece is going to be a contrasting color. It's going to give a little bit of a decorative element, as well as just it's going to keep the chopsticks in the air off of the tray. And the handle part, where you hold on to, they're going to be kind of just here in a small fluted area over here. And so now most chopsticks, they will range in length from 7 inches to up to 10 inches and everything. The set that I have is 8.5 inches in length. But again, it depends on, what set you would buy for your, and everything, your length and all. But mine are 8.5 inches. So I will just draw a reference rectangle, 8.5 inches long. And what that does is when they're resting here, and there's going to be a little recess in the piece that gets made here. When they're resting here, this shows me where my little chamfer area is going to be. And I don't want it off to the side. I kind of want it centered. I want a little bit of, I want it centered. So let me get this centered on the table, left to right. And then that'll tell me where I can put this piece and where I'm going to create the kind of chamfer area that my sticks will sit in. Now, the chamfer, not chamfer, but the little flute that we're going to do here doesn't have to be, very wide or anything like that. It's only 2 chopsticks and all. But I want to make it kind of consistent with the width of this. This is 1.25 inches here. And so I'll make this area kind of 1.25 inches. And it is close. It's 1.2. And then I will get it to align with this piece using the alignment tool, aligning up and down to get it to align there. Okay. And then my sushi will, this will be the area here where my sushi will go. My single serving, sushi rolls and all that stuff. Okay. Now, let's start creating the tool paths and everything for these, and then we'll talk about making this part because it's a separate piece. It's going to be made out of the same parts that my legs get made out of, because I want it to be the same kind of contrasting material, whatever color it is, and everything. So we'll talk about this part here, and it's going to fit in kind of an inlay, and it's going to be a removable piece. I wouldn't glue it in case, food or something or stuff, gets on it. That part can be taken out and cleaned separately and stuff, whatever. But it's going to be removable, this part here. All right. So on my trays here, since my router bit is going to be pocketing and it's going to be creating, kind of the radiuses anyway on these parts, I'm going to go ahead and add the fillet in now. And I'm just going to be using a 1/4 inch end mill, so it'll be an 1/8 inch fillet. And I'm just going to add that fillet to all 4 corners of this. Okay. And I'll have a larger fillet for that back part here. And we'll talk about the recess that we're going to be making here in just a second. Let's do the pockets first. So this pocket and this pocket. is going to be seriously a very shallow pocket. It's literally just enough to create a small indent to show that it's separate from the rest of the tray, that it's meant for something, you know. So it does not have to be deep at all. A 1/16 inch or less, you know, you want some depth, but it doesn't have to be a great amount of depth. I'm just going to go 1/16 of an inch, and you could use, if you had a small bowl and tray bit and you wanted little radiuses and everything, you know, to the edges and stuff, you wanted a little radius and all to it, use a bowl and tray bit for that. That would change the radius here, you know, depending on the diameter of the bowl and tray bit. On my bowl and tray bit, I have the 7/16 inch diameter, and it has a radius of 1/8 of an inch and everything. So that 7/16 inch diameter, I could, that is, what is it, 3/16, a little more than 3/16 radius, right? So let's use that. Let's change our fillets here. I'm going to change the fillet. It doesn't really matter, but I'll change it anyway. All right, so 0.4375 divided by 2 equals 0.21875, and I'm going to change that radius on these 4 corners. Again, not necessary. It would create its own radius if you were just doing it on the square. Doesn't matter. I'm just doing it for the design. Visually, I want to be able to see it in the design here. All right, let's go ahead and create those 2 pockets. And I'm going to be going 1/16 of an inch deep with that bowl and tray. And this is going to be my ginger and wasabi pockets. Probably did not spell wasabi correctly, but you get the hint. All right, let's go ahead and preview those. Okay, so just those very shallow recesses. Everybody with me? Y'all still with me? Let me know you're with me in the chat. And because I don't see the chat moving, I want to make sure I'm not chamfering and all that stuff. All right, so that's going to be that. Now the bowl pocket, I can use the same bowl and tray bit for it and everything to kind of create that rounded edge, or I could just do a pocket cut, because again, it's just going to sit in there and all that stuff. It really depends on that. And now some people actually carve the soy sauce hole or recess in the sushi tray, where they actually pour the sauce right in on the wood and all that stuff. I like using the bowl, but it's totally up to you. Now this one's going to be a little bit deeper. Okay. Now the overall height of those trays was, let me look again. Bear with me a second. Bear with me just a momento. The overall height was 0.8 inches, so a little over 3/4 inches tall, just a little over 3/4 inches tall, right? And so, you know, at 3/8 of an inch, we're halfway. We're about halfway, you know, at 3/8, and I got a 2-inch diameter. This is overall 2 3/4. So let's go. Let's go 0.3. 0.3. All right, let's calculate that. And let me rename that so I don't, this is going to be my soy sauce or whatever sauce you use, duck sauce, whatever sauce bowl. All right, preview that. Okay. So that's where we're at. Again, this is waste over here on the sides and everything. Now, this is going to be a pocket cut, this here. It's going to be a shallow pocket. And again, there's a piece that's going to fit in it. Let me see if I can find an image to show you what I'm referring to. Bear with me a moment. It's not going to be this particular design. They're using some, kind of a fork design or whatever. Let me see if they have a side view. Okay. So you see this piece here and everything, right? You see that? It's going to be a removable piece. So you can set the chopsticks off of the tray if you want to, or you can use them on the tray, that type of thing. Now they're using what's called a Tory gate design, which is kind of that, that horn look, but it's a removable piece. So that way you can set the chopsticks off on the table and the ends are up. They're not sitting right on the table, where you're eating, it's going in your mouth, or they can sit on the tray itself, right? So that's what that piece is going to be. Now we're not doing this design here. We're going to kind of do a double design and everything, but that's the premise of it. Okay, it's a removable piece, so you can set your chopsticks on it. Okay. All right, so let's get back here. All right. Still in it. Cool. Awesome. All right, so this pocket here, this little pocket's just going to be a shallow pocket for this removable piece to fit into. So it's going to be a pocket cut. Now, we have to remember whatever part fits in here and everything. It's going to be a nice little friction fit. It's not going to be it's going to be something that can be removed easily. It's not going to be like an inlay, like a tight fit. We're going to be doing the inlay last here in a minute. But it's going to be we just have to remember that these square corners here are going to get radius depending on what bit we use, to cut this pocket. And I want to minimize the radius on this one, so I'm not going to use a 1/4" end mill for this. I'm going to use an 1/8" end mill, but I am going to use an end mill because I am going to create a square walled pocket that this part's going to fit down into, that it's kind of like a holder for it or what have you. And so for this pocket cut, we are going to cut, my piece as a whole is probably going to be 1 inch tall, the little holder, and 3/4 inches tall. So my pocket, let's go with a 1/4 inch deep, and we're going to use an 1/8" end mill. And this is going to be the chopstick rest pocket. 0.125 end mill. All right, let's calculate that. Okay, so that's going to be that pocket there. And then I'm going to create this little fluted area. It's going to be it's going to be an area that's going to be, it's going to start flush, and it's just going to like recess downward, like a taper, if you will, and everything. And kind of like a ramp, if you will, that kind of points up to here. And so the toolpath that you can use for this, it really depends on what toolpath you want to use. I'm going to just use the fluting toolpath for this. but it could also be, you could also use the chamfer toolpath as well. In a sense, you really could, and everything. So it would just be a shallow cut. It'd have to be a wide angle bit, you know, like a 120 or whatever. All right, so let's get this done. So for this, literally, again, it's going to be just a shallow pocket. So no more than a 1/16 of an inch. And you can use whatever, you know, bit, you know, will work. I think the ball nose bit will probably be the best bit to use to create a nice finish. But I'm going to actually use the bowl and tray bit that I have because it's my widest bit and it's wider than my 1/4 inch ball nose. So my bowl and tray bit is the white side 1370, by the way. White side 1370. It's the 7/16 bowl and 1/8 inch radius bowl and tray bit. Could be a 1/4 inch radius, but I think it's an 1/8. All right. We're going to ramp over the full length. Okay, we're going to ramp over the full length of this. And now, when I do this as just so you understand fluting, if I do this as a rectangle, if I calculate this, okay, and everything, and I go to preview this, what it's going to do is it's going to follow that single line, right? And it's going to keep getting deeper and deeper as it goes. That's not what we want. So a rectangle for the vector is not the vector that you need. You need a straight line vector or series of. So we definitely don't want to do that because all that did was it followed that single line and it got deeper and deeper until it got to the end of the path from the start to the finish. That's a no-no. We don't want that. We don't want that to happen. So this is my area here. But I need to draw a straight line from here to here. And I'm going to step over that line. Okay. I want to step over 40% of my bit would be fine, right? So I'm going to step over and on my 0.4375 divided by 4 equals 0.10. So 0.1. An eighth of an inch is fine. Yeah, we'll go an eighth. 0.109. Close enough. And I want to step over, and I want to keep stepping over all the way across my little box. Right? Now, we do not want this end line here, and we do not want this center line here, because remember, that's where it's going to start and stop, right? So we're kind of dealing with half the bit already and everything. So the bit's going to be cutting the center, you know, is going to be following this line. So we're not going to use this first line. We're not going to use the rectangle. We're not going to use this last line. Okay? But we are going to use these lines here. And so once again, we're going to open this fluting toolpath back up. And we're going to follow these lines going, you know, from the starting point back. So that's why I drew the lines from left to right. We're going to ramp over the overall length, that 1/16 of an inch. I'm going to reset the preview back to a blank board. And I'm going to preview all of the cuts again. I don't know why it squishes like that on my preview. I think it's because I got the setup too high. I have no idea. But when it's finished, it'll snap back to what it's supposed to look like. Okay. And so going to have to do a little bit of touch-up sanding and everything, you know, here. There's no real kind of profile outline option on this, you know, to, you know, do a profile pass last or any of that stuff and all. So that bit's going to come and bump bump, 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 bump. So this last little bit back here, I'm not going to try to take my bit and clean it up or any of that stuff. I'm just going to, just some light sanding and everything. And all it is just a recess, just a slight little recess. So my chopsticks aren't sliding all over the table when they're sitting in there. You know, it's just a place to kind of, just to catch them, right? That's all it is. It's the only purpose. It's only purpose it serves. All right, now let's really quickly I'm going to take this vector here and I'm going to drag, I'm going to hold down my control key and I'm going to drag a copy out to here. And I'm going to lay out my rest area. So the rest area is going to be, as I said a moment earlier and everything, it's going to be a 1/2 inch tall, or 3/4 inches tall, sorry. And it's going to be 1 1/4 inch wide. That's how wide that is. Okay. So that's that. And it's going to have just a nice gradual kind of recess here and out. So the let's go with a 1/8 inch. Let me see. Better yet, I'm going to do it a different way. I'm going to go into node editing. Before I go into node editing, I'm going to use my layout lines to help me out here. So what I want, here's what I want. From the left side, I want to come in 1/8 inch. 0.125. Okay. And from the right side, I want to come in 1/8 inch. That's a negative number. Now, from my center line, so imagine my center point here. All right. I also want to come in, or out from both directions on this. We can go 1/8 on this, and also a +1/8. Okay, to create that. And then I want to take, and since this is a side view here, so this is what my part looks like, right? This is a side view. I can go ahead and go into node editing now, and I can insert points. I can insert a point here. And get up close and personal so it lands right on it. I can insert a point here. Here. Oh, missed that one. Zoom in and drag it over. And insert a point here. Now, between these points, I can turn this into an arc and pull it down. Doesn't have to be a full arc, just a nice subtle recess, right? And I want to, I want to change this to an arc. And I want to pull that down. And I want to kind of snap to this one here. So I want that to be the same. And then I want to soften, I want to kind of smooth these up here and everything here. So I can select all of this on the inside. Let's try that again. And I can just hit the letter S. I should be able to hit the letter S. Are you not going to? It's not going to. All right, all right, all right. It's not going to let me smooth that point. That's fine. Let me just do this then. It's not going to let me smooth that point because there's no Bezier curve on the left or the right of it. So that's fine. I'm just going to use my fillet tool. And on my fillet, I'm just going to go 1/8 inch. And I'm just going to fillet this. Okay. And that is going to be the vector for my part that gets cut out for the rest. Okay, so that's that one. Don't need this. So my 2 legs and my part there. Now, the main attraction of this sushi bowl is going to be a V-carve inlay. Okay. Hey, thank you, Polly. The main attraction of this bowl is going to be an inlay. We are going to do a V-carve inlay. Now, contrasting colors, right? So let's say that this sushi platter, I could mix all kinds of woods up. I want you guys and girls to understand that this could be a scrap wood project, right? You can take multiple species and glue them together. You can create, single species. You can, cut-offs. They can be, all types of, rough sawn, wood that you might not use in another project because it has a defect or something in it. I mean, there are so many different things that you could do with this, right? You could, with these sushi trays, you could add in, that's not a sushi tray, that's a cutting board. Let's back it up, Jack. You could add in, and look at the prices on these, $245, $135. Let's look at this one. So, this one's got a nice little cherry or bloodwood type strip down the middle of it, right? So, again, it could be any type of your charcuterie boards and things like that. You could literally assemble whatever you want to make your blank out of. Your blank could be anything, right? And in my case, let's say that I'm using a walnut blank because I do have a piece of walnut that I got for this project. And my accents, the chopstick rest and my legs, they're going to be a maple. I like that. Or they could be cherry, a little bit lighter color as well too. Cherry is a nice color as well. But I want to go maple because my inlay is going to be maple. I want that contrast of my inlay. Now, for the inlay, it's going to go right in this area here. I have some nice choices that I could do, the V-carve inlay. And the first choice, let's import a vector. And I'm going to import the peacock vector here. So let's take him, not counting the circle, group him together, and size him appropriately. And remember, this is that chopsticks, I don't care where the inlay lands or falls or what have you, right? So, the inlay can take up quite a bit here. So, for the board, I could do something like this, right? A beautiful kind of a peacock inlay, because peacocks are Asian, right? So it kind of fits. All right, so that's option one, right? Or, we could go with a koi fish. Bear with me. Group him together. We could go with something, like this. And just to give you a visual, right? Let's do a V-carve toolpath so you can see visually. We'll go with a 60-degree V-bit just for visual purposes only. This is not going to be used. But no end mill, calculate. Now I'm going to add some just black color to this, or what have you, a little bit darker. We'll go black for the minute. Just so you can see the image, but you know, so that would be, you know, it's going to be, that could be, you know, one of the options, right? Let's look at, all right, so that's there. And then we got one last option. It's another koi fish. I'm going to provide these vectors to you guys and girls. So that's why I'm showing them to you. All right, so this one. Let me group him together. All right, and so that's that one. Let me show you what that would look like. We'll create a VCarve toolpath. Just a VCarve toolpath just gives you a visual and everything. It's going, it's going. All right, we'll just preview this one without the other stuff, just so you could just see the image itself. All right. And so, you know, that could be the other design, right? And so now if I did individual platters, individual servers, right? You know, for sushi for two, sushi for the party, whatever. I would have a set, right? They would have a similar theme to them, right? They might have the same pattern engraved on them or inlaid or whatever the case may be. So whatever, you know, if I was doing a peacock, it would be a peacock on all of them kind of thing. If I was doing a set, if I had a set of 4 of these individual servers, right? Or 6 or 8 or 10, I don't care. If I made 100 of these, right? But if let's say a set of 4, you know, family of 4, family of 5, whatever. I stick to one pattern, right? It wouldn't have like a bunch of different patterns on it all. It would be a set. You know, matching chopsticks, the sushi bowl, the you know, and all that stuff. You know, the thing that's going to vary is the wood, right? The wood, you'll try your best, you know, but no 2 pieces are going to be the same, right? And for this, we're going to do the peacock for this one. I want the peacock. Or a peahen if it's a female, right? Peacock for a male, peahen for a female. But in this case, we are. Did you know that? Did you know that? Did you know that? Did you know that? That's what you call a female peacock, a peahen. Okay. I'm gonna size this up. I want her right in the middle of those bowls. So I'm gonna have this beautiful pattern, and let me just show you what this looks like carved. Do a VCarve toolpath on it. And then we're going to talk about the inlay. And this is it. When we do the inlay, guys, we're going to kind of wrap it up with the inlay. But I want you to learn how to do VCarve inlays. So I'm going to teach you here in just a second, inlays. Right now we're just we're getting the design kind of figured out and all that stuff, right? Okay. Now, if I wanted to, depending on how much time and effort I wanted to put into the design, okay, I could do more than one contrasting color. So for instance, on the feathers here in the tails, I could take on the larger areas, and let me turn off the color so you can see the holes in the caverns and everything, right? These larger areas here, those could be inlaid with purple heart, as an example. These circles in here, you know, I could use a maple. I could go with a cherry, bloodwood. Hell, there's so many different species, right? I could go with a dark wood, depending on what it was. Now in my case, I'm just going to do one maple, right? Just one maple inlay, just a basic inlay. You know, but if I were going to, I could separate and create the toolpath, the inlay toolpaths for each of these larger recesses where my mouse is here. I need to change my mouse color one day for you guys and girls. But where my mouse is, I could do, you know, different recess, you know, inlay colors, purple heart and then maple and then cherry or whatever. And I could, you know, give this peacock some color, right? And everything. In this case, I'm just going to do a nice soft maple just to create that nice contrast color on the walnut. The walnut wood is going to be kind of a dark walnut. That's not it right there. It's not it right there. I don't know why Vetra calls that walnut, but it's going to be, you know, kind of a dark walnut and everything. And the contrasting color that, you know, I'm going to do with this is going to be, you know, kind of a maple. And this doesn't do very good at showing the contrast and everything, but it doesn't show the fill very well. But because it's not carved in, it's an inlay, right? It's flush. But, you know, I'm going to do kind of a contrasting color with that just to kind of give it a little bit of decoration. But again, I could go hog wild with this and I could spend a few extra minutes and do a glow up with purple heart and maple and cherry and whatever, right? If I wanted to really, you know, get creative and everything, I could find some poplar that has like an or an ambrosia maple that has some reds and whites in it and everything. You know, ambrosia type maple, or a poplar that has some real green tints and everything to it and all. And I could really just whatever, right? That kind of thing. In this case, I'm just doing a simple solid color. And that's what we're dealing with. Okay, so this is my layout. Now let's talk about a V-carve toolpath for a moment. And let me see if we can get you to understand a V-carve toolpath. And the properties of it and everything. So let's come over here and zoom in over here for a moment. Okay. Dum 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 dum. First things first, when you have a design, let's say that this is my design here. Bear with me. Bear with me. We'll call it the female of the pocket. All right. When you're doing a V-carve toolpath, your female is your original design, you know, getting pocketed out. And then your male is a copy of that, you know, that original, but it's going to be mirrored. So it's going to be flipped horizontally and there's going to be some type of boundary around it. Okay, while the female is getting pocketed and carved in, and let me move this male out of the way for a moment. Move that. Well, it would help if I let me connect my pieces together. Give me just a moment. Okay, let me select those two parts and join them together. There we go. All right, let me move that out of the way. Okay. You have your female pocket as your original design, whatever it is. In this case, my peacock, you know, how it's laid out on my cutting board as of now. And you have a certain depth that you're going to cut. And when it comes to things like, you know, signs and stuff like that, you don't have to go very deep with your inlay. But when it comes to cutting boards and things like that, things that might get water on them, or they might get in a dishwasher, they might get something, you want some depth to your inlay. And in order to achieve that depth, you want a narrow angle V-bit. Now you'll see if you ever go look at YouTube channels. Hey Bruce and Big Daddy Fish, thanks guys, I appreciate you. I just now seeing that super chat. I appreciate you. Thank you very much. Oh, that makes my day, and I appreciate you so much. You have no idea how happy that makes me. Okay. The inlay, if you look up V-carve inlay on YouTube and you see all the different inlays and all, a lot of times they're using a 90-degree V-bit or even a 60. Even in V-carve inlay classes that I've taught in the past, I use a 60-degree V-bit. But you're only going to be able to get so deep with a 60-degree or a 90-degree V-bit. Okay, there's only so deep you can get. And in this case, we need to get some depth. We need some meat to our inlay and all. So we want to use a narrow angle V-bit. A good V-bit for this would be like the Whiteside SC50. 22-degree included angle, 11-degree half angle. That'll give us some depth, right? The narrower the angle, the deeper we'll get and stuff. So, but we do need it to be a V-bit, right? It can't be just an end mill, right? It's going to be a V-bit and everything. So, in the case of this inlay, with it being on this sushi platter, I'm going to use a 22-degree V-bit. And my depth, my pocket depth, the female pocket depth, is, you know, from the top of the board down to the bottom of the pocket, how deep the pocket's going to be. Now I'm going to set, that's a flat depth. We're going to limit the cut to a certain depth. The flat depth is a limit. I'm going to limit it to, in my case, we're going to go 0.25 inches deep, so a quarter of an inch deep, or 6.35 millimeters deep in this case for this inlay. So, and if we were to look at, let me put my drawing back here for a minute. Your female, which is highlighted pink right now on the screen, the top of the material down to the bottom of the cut, okay, that's your pocket depth. All right, that's the depth of the pocket. And in this case, our pocket depth is going to be 0.25 inches or 6.35 millimeter. Okay. Now, when the male fits into the female, there's only going to be so far that it can fit in before the sides of the male and the sides of the female come together. And the remaining space that's left, once the two parts fit together kind of as tight as they can go, that is your glue gap. It's also referred to as glue space. That's your glue space, right? And we want to have glue space, but we want to keep it as minimal as possible. So our glue space that we're going to have is going to be 0.039 inches of glue space, 1 millimeter. Okay, so a little over a 30-second 03125, right? In this case, it's 039 or 1 millimeter. That's how deep, that's how big our glue gap is going to be for our parts. Okay, now when the two parts do come together, when the two parts press together, there needs to be some kind of a space or gap between the top of the female, top of our board, and the underside of the male. There has to be some kind of gap there so we can remove, when glue all dries and stuff, we have something we can put a bandsaw in between, a handsaw. We can take our CNC and mill it down as well too, so we can do that at all. But we need to create that clearance. We got to have some type of clearance. Now for me, I like a clearance of around 2 millimeters, which is 0.078, a little over a 1/16 of an inch. 0.0787 if you want to be exact, but 0.078, 2 millimeters is going to be that clearance. So that's the clearance is when the two parts are together, the space between the top of our project board and the kind of the bottom of our opening where our male part, when it's fit in. So that space, that gap there, that's called the clearance. The clearance. Okay? Now, the distance when our two, and I have space in here. Now keep in mind, I have a space right here and everything, and a space right here. Let's pretend that's glue gap, right? The two parts have been pressed together. They're fit nice and tight and everything, and we have our contact area, and we got our glue right there. Our glue creates some volume. There's glue there, right? So it takes up space and everything, and that's what this little opening is here. That's our glue space. So if you're wondering why the two lines aren't touching right now, it's because it's glue space. That's what it's visual. That's what it's visualizing. Now, the distance from the top of our project board to the bottom of the male part, okay, when we're at full contact, all right, that is our contact distance. That is our contact distance. So this line right here at the top of our board, and this line, which represents where the bottom of our male comes together when it's fully inserted, that is our contact. How much meat, how much contact that we have of our, how much inlays inside of our, how much of the male part of the inlay is inside the female, right? How much contact we have of meat, right? And we want a decent amount of meat. In this case, we are about, of contact, we are about 0.211 inches, about 5.35 millimeters. So about 211 is how much meat is inside of our inlay. Then that remaining distance, because remember, our pocket was 0.25. If our contact is 0.21, then that, that 1 millimeter is our glue space. Okay? And then the distance from where when our male is fully inserted, the distance from the male's bottom, when it's fully inserted, to the top of our clearance, that is our plunge depth, right? That's considered the plunge depth in a V-carve inlay. Okay? In this case, it's 7.35 millimeters, and we're going to talk about this a little bit more so you understand and everything when we flip the part over. So let's do that now. Let's take our male and move it over here, and let's turn it upside down because that's how it's going to be carved when we carve it on the table. We got our router bit. Let's take our router bit here, and in our router, right? All that wonderful jazz. Cool beans. Okay, now, regardless of what part you're cutting, okay, Z0 is is always the top of the part. Okay? So when we're cutting the male piece out, you know, we have our male scrap piece of wood or our inlay piece, you know, laying on the table. We're getting ready to cut it out. The surface of that male is Z0. That's 0. When we tell the V-carve toolpath to, you know, we have a start depth and we have a flat depth, right? Well, on the female pocket cut, our start depth is 0, the top of our board. Our flat depth is the distance we're cutting to, and in this case, it's 0.25. Okay, that's the female. I'm going to be using a 22-degree V-bit, which has an 11-degree half angle, 22-degree full angle, that or included angle. That is the white side SC50. The white side SC50. And my female inlay is going to be calculated to cut that. Now, of course, we're going to be calculating it on the peacock here. Not that one. I don't know where that one came from, but let's turn that one off. Okay. So when I'm doing the female toolpath here, it's going to be 0 start depth, 0.25 flat depth with a 22-degree V-bit, and this is going to be my peacock. Female inlay. And, oops, calculate. And so that cut is going to start at 0, and it's going to cut down, but it's going to flatten out at 0.25. Let me turn off the color here, and let me change this walnut to a lighter wood so we can visualize and we can focus on the cut itself and not the wood. Okay. So we got some depth. We got good depth on this inlay female here. We've got good depth on all the parts and everything. And it's starting at 0, cutting down that 0.25. Okay. So that is going to be the female inlay. Now we are going to set up a new sheet, and this new sheet is going to represent our male piece of material. This is going to be our male inlay. For the male inlay, the part here, the peacock is only about 4 3/8 inches wide by 5 3/8 inches tall. So 4 by 5. So let's call it 5 by 6, right? Okay. So my male needs to at least be, 5 by 6, right? My male piece of wood, right? It has to fit in there 5 by 6. So we're going to go here, and just to give me some room, and stuff, I can cut off all my excess and everything with, a bandsaw or whatever later. But I'm going to go 5 inches. I'll go 6 inches wide, 7 1/4 inches tall. Stand by. And I'm going to, my inlay piece doesn't need to be very thick. So a 3/8 inch piece of material will be fine for this. 1/2 inch piece. You can even do it out of 3/4 if you don't have that. But it doesn't need to be very thick, right? Because anything beyond 0.3, basically, all that remainder is going to be waste. Right? Going to be middle way. So in this case, I will probably bring myself to about we'll just go a 1/2 inch piece of material. Stand by. It's creating the sheet. I do not know why that's dragging. Hold on a minute. Okay, we're there now. All right, so now on my main design, I'm going to take, let me get back over to my main design here. I'm going to take my peacock here and I'm going to copy it to another sheet, and it's going to be that male inlay sheet. I'm going to copy it over. And I'm also, my vector drawings and everything over here, I'm going to copy that over too, so I can show you, so we can continue talking about that. Copy that over also. And now, wait for it. On my male inlay, let's get it centered on the board. And immediately we're going to flip it horizontally. Horizontal flip. And we're going to put a boundary around it. Now, we want on the boundary and everything, make sure your boundary is at least wide enough that you can, because when the walls get created, we're going to be cutting those off with a handsaw, bandsaw, jigsaw. I don't care what saw you cut it with, but we are going to be cutting the excess away, the waste area out here away. So we need to make sure that our border is not too close to our design to give us room for that cut and all, but it doesn't have to be too far away either. So we can, we make sure our router bit can get in between and fit in the areas and all that good stuff, but we don't have to be too far or too, close or what have you. Just kind of, find a nice area to create that border, that boundary. Okay. In this case, I'm using a rectangular boundary. Heck, it could be any kind of boundary. It could be a circle. It could be a oval. It could be a wiggly line that I draw. I don't care. It's just some type of boundary surrounding the design. Now, in the case of this, we are going to be cutting all of this material away around the peacock, and the peacock design itself for the male is going to be raised. So if any of you have ever done a raised design where you have a boundary surrounding that design and it carves around that boundary and those letters are raised and things like that, same principle here. Everything's going to be carved around this, and all of these areas are going to be raised so they can fit into the female part. Now, we need to determine how, if our cut is going to be, 0.25 inches deep, and we want at least 0.039 inches of glue gap, 1 millimeter, right? Then we need to figure out, what our start depths are, what our flat depth is, and all of that stuff. Now, just so you know, when the part gets cut here, let me just draw a line here. I'm going to draw a line here. And I'm going to draw a line. Hold on a second. And I'm going to draw a line here. Okay. Now, when we're doing the male, there is a start depth and there is a flat depth. Okay. And your 0, no matter what, Vectrix Z0 is the top of the material. So when we tell it to start, at a certain depth, and flat depth, what it's referring to in the case of a V-carve inlay, it's referring to that clearance that we have decided to create. That clearance, in this case 2 millimeters or 0.078, that clearance that we want. Okay? So in this case, we're going 2 millimeters or 0.078 is our depth. Now what that means is, okay, that's our clearance. That's our start depth and our flat depth. And the distance from this line to this line is going to be 0.078. Okay, a little over a 1/16 of an inch. So from the top of my material, 3/8 inch thick piece of material, I'm going to have a start depth going down a certain depth and then a flat depth. In this case, my flat depth is 2 millimeters. Okay? Or 0.078, sorry. So the math, this area here plus this, okay, that's what I need to fit. It needs to add up to at least my pocket, 0.25. But in this case, it's going to actually add up. The distance is going to add to that plunge depth. The distance is going to actually add up to 7.35 millimeters or 0.0289. 0.0289 is our magic number here. Okay? What that is our 0.25 millimeters. Our 0.25 inches. Sorry, I don't normally work in millimeters, but I'm trying to help everybody out here. 0.25 inches plus our 0.289. That's the 0.25 plus that 0.078 equals that 0.29. Okay? 0.289. So the toolpath, where's my mail here? When we select this, it's going to be a V-carve toolpath and the start depth. Now, for some CNCs, depending on how deep your inlay actually is and all, that's a lot of material. If we start at 0.289, right? That's my full cut minus 0.078 equals. So 0.211 is my start depth. My 0.078 is my flat depth. Now, that 1/4 inch start depth, so that bit, there's no passes. The V-carve toolpath is going to have that bit plunge down, and it's going to cut and try to remove all of that material at the full cut. The full cut. And when I say the full cut, I'm not saying it's starting from 0 and it's going to come here. It's going to start at 0 and it's going to come here. The full cut it's going to do in a single pass. And that is a lot, and this should be 0.078. That 2 millimeters, or that 0.289, so almost 3/8 of an inch deep, that could be aggressive for some CNC machines out there. For the, the Shapokos and the X-carves and things like that, that could be an aggressive cut. So that's why for the mill, we are going to create multiple tool paths leading up to this final tool path here. We're going to take shallower and shallower cuts, either 1 or 2 additional tool paths. In this case, I'm going to do probably 2 additional tool paths until we get to this final cut here. So, in the first tool path, give me a second here. In my first mill cut, and let me see if I'm confusing you. Stay with me, stick with me. This will make sense when we get all the toolpaths created. Then we'll go back over it again so you understand the math and all that stuff and everything. But so on our cut here, on our mill cut, our first toolpath, I'm going to just take a small shallow cut of less than a 1/16 of an inch. I'm going to go 0.05. I'm going to go 0.059 or 06. 0.06. We'll go just 0.06. Basically 1.5 millimeters is what I'm going there. And I'm going to end at 0.078. Okay. So from here, I want to take that 2 millimeter cut. Okay. Start here and here. So now, if I add those, and let me break up my calculator right here for you guys and girls. If I am starting at 0.06 and I'm cutting down another 0.078, that brings me to 0.138. Okay? 138. So now, and remember, my end goal, when everything is all said and done, my end goal is 0.289. So this is our first toolpath. So this will be mill, inlay, cut 1. This way we're not taking too deep of a cut. If it's cheap, you know, basswood or whatever type of wood and all, it breaks away and chips away. If it's just too aggressive of a cut and too little of an inlay, you know, you could chip away and all. You could break a bit if your bit's, you know, whatever. You could damage your machine if your cut's too aggressive. So we're sneaking up on this final cut. Okay, we're sneaking up on this final cut. So we are starting at 0.06 and cutting to 0.078. And that brings us to a total cut of 0.138, right? So if I take my 0.289 and I minus my 0.138, right? Still got 1.151 to go, right? So my next cut is going to start. So let me calculate this toolpath first. Calculate. Okay. So that's going to come in and that's going to cut down to that first level. So it's not such an aggressive cut. Okay. And then the second toolpath, let me get through this one. Okay. So that's our first one. Wonderful. Now the second toolpath is, the second V-carve is going to start at that 0.138. Okay. So that 0.06 plus 0.078 equals 138. So that's where the second cut is going to start. 0.138. And we're going to take, so this will be our mill inlay 2. Okay. Cut 2. Cut 2. And then our final cut is going to start at that 0.216. Actually, it can start a little bit more. Let me see what. Stand by 1 second, because I want to use that 0.2. 0.289 minus 0.216. I believe that's what it was. Yeah, equals 0.073. Right. So I want to be at 0.078. I want to take that, you know, that 0.078 cut to end up at my final cut there. So I'm going to take and make this 0.211. I'm going to start at 0.211 and end at 0.078 for my third cut. So my third cut, and that just keep me straight. I want to keep this 0.078 in there. So I'll start at 0.211. All I did was I subtracted that 0.005 from that 0.216 I had. So 0.211 to 0.078, that two millimeters in my case, but that, you know, that final cut, that's my glap distance. That's where I want to end up. Okay, so now this is my final mill. What will happen is the first pocket brought us down to this level. Okay. The second pocket is bringing us another 2 millimeters down, or, you know, get familiar with millimeters, but I'm working in inches, so 0.078 down, another 0.078 down to the next level. And then wait for it. Very good. And then the final cut is going to take us to our final step, our final pass. And that way we're not trying to take the full cut. Hello, Lynn. How are you doing? That way we're not taking the full depth of cut in one single pass. Because if we just set our 0.211 and 0.289, you know, our 2 millimeters, 0.078 from that to make it 0.289, that 0.211, that cut depth that it's carving, that depth, when it gets from, let me get over here. When that bit comes, it's going to start here and cut here, but it's going to be taking this full pass. If we were to tell it to start at 0.211 and cut down to 0.078 from that, it's going to take that full cut, that whole 3/8 of an inch, not 3/8, but that whole 289, cut in one single pass. And that could be hard on our bit. It could be hard on our material. It could be hard on our router, depending on how, you know, strong our CNC is or not and everything. So take your mill inlays and split them up. Okay? Split them up. We took, from each pass, we took 2 millimeters, 0.078, a little over a 1/16 of an inch for each cut. Okay? Until we got down to that final cut. So, you know, a 1/16 and a 1/16 is our, you know, 1/8, and, you know, we're starting at, you know, whatever depth we're starting at, but don't do what I just said. Don't think of it like 1/16 and 1/16, but we're taking, you know, small chunks to end up with from the top of our material, Z0, down to our clearance cut, you know, this flat depth here, 0.289. And what that is again, that is our pocket depth, our plunge depth. So if I take a copy of this mill, let me move this Z0 out of the way. If I take a copy of this mill and I flip it, and I align it, when that part gets pressed in to that female, and we end up with our glue gap, when that, it fits in, it's going to press in as far as it can. The glue is going to create, pressure and all that stuff and everything, and you're going to get glue squeeze out and all that stuff, but it's only going to go, the contact is only going to go so far. Once it's made contact, that clearance that we're shooting for, that 2mm clearance, that 0.078, that's the depth that we're removing from each of those cuts, right? And everything. But our overall cut from Z0, think of it upside down, to here, that's our plunge depth, and that's 0.289. So that's what those numbers should all add up to. When I add all of this up, it should equal 0.289. And it's going to be a little bit more than 0.289 because I've subtracted 0.005 from this cut to make it match. But that's to get me to 0.289. So if I were to break out my calculator again, we started at a 16th, 0.06, roughly 16th. We add in that 0.078 for a total of 138. From there, our second cut, I went ahead and had it start at the 138 and go another 0.078 to bring us to 216. And then the third cut, I wanted to take another 0.078 from that. But if I did, that would take me over my full 0.289. That's my goal, 289. So instead of starting at 0.216 and cutting 0.078, which would have shot me over my 0.289, I simply subtracted from that second cut, that 0.216 total, I simply subtracted 0.005 from that. And that gave me 0.211. So then when I cut down that 0.078, that brings me to my 289. Hopefully you understand that. All right? Hopefully you understand that. Okay. Now, the larger clearance area, it does not have to be, Daniel asked, does the larger clearance area have to be cleared with the, a larger bit and everything? No. You can use clearance tools. In my case, I used an 1/8 inch clearance tool. Not just the V-bit. It's doing two tools. There's a 22-degree V-bit here and an 1/8 inch end mill doing the clearance. So I don't need a big 1/4 inch end mill. I'm using an 1/8 inch end mill, and the 1/8 inch end mill is doing the clearance area while the V-bit is doing around my V area here. Okay? And this inlay, while it looks funky and everything, that's exactly what it's supposed to look like to fit into my female pockets and everything. And we've got good amounts of meat and all that stuff. But in this case, Daniel, there is an 1/8 inch end mill doing the clearance, and the 22-degree V-bit is doing the edge work. Now, when it's all said and done, you're going to take a handsaw, bandsaw, I don't care what kind of saw, and you're going to cut off the excess of material You're going to get rid of that excess of material. Okay, need to go a little bit deeper. I forgot my board is a 1/2 inch, not 3/8. But you're going to cut off that excess material so that you can glue that female into that male with no obstructions and everything, right? Because it's got to be able to fit in there. And when that male goes into that female, the space that we have left over from the top of our project board, in this case our sushi board, to the bottom of this male cut inlay, that's our clearance, that 0.078, our 2 millimeter clearance in my case, so 0.078. Now, this is going to give me a nice deep inlay, a decent deep inlay and everything for this type of cut and all. And so I don't have to worry about, it being too shallow or and all for water damaged areas and everything. So that is that. And let's see here. Or are the clearance toolpaths done with a different bit if I missed that? Yeah, you guys are lagging behind me, so I've already answered that question. Daniel, you'll get that answer in just a moment. Gluing. How long does it take for Titebond to take to fully cure? Would epoxy do better? In this case of this, in case of this being a sushi board, I would use Titebond 3 because of its water resistance and everything. I would not use epoxy on an inlay. I would not use epoxy on an inlay. I would use wood glue. Titebond 2 for regular inlay type signs and stuff like that. Titebond 3 for cutting boards or, anything that, might have, fluids or juices or waters and all. So, Daniel, to answer your question, no. You're only doing 2-bit changes. This is when we calculate the toolpath and everything. Your male cuts are all using the same 1/8 inch end mill. So all the 1/8 inch end mill work can be done. And in the V-carve, it can be done because it's going to cut in the same depth order in the profile. So you're doing all your 1/8 inch bit, then you're changing to your V bit, and then you're changing back to your 1/8 inch for your final cutout. No, I'm sorry, you don't need to change back. You can use a bandsaw or handsaw to cut it out. You don't need to cut it out on the CNC. So end mill first, V bit last. Daniel Bradner. So no, not a lot of bit changes on that. 1 bit change, 1 tool change. And Big Daddy Fish, yeah, Bruce, Titebond 3, when not exposed to air, will take longer to normal cure. The glue ups and everything, I allow before I surface, like if I'm doing multiple glue ups, where you're doing sections and things. And by the way, if you have a large inlay to do, try your best to break it up in sections. If you're ever curious, here, let me see here. YouTube.com. There are 2 videos that I recommend for deep inlays and all. Number 1 is this one right here by Stefan Forcelli's Deep V-carve Inlays. He does a phenomenal explanation of deep inlays and everything. And you'll see some similarities because he's who I learned from. And the second one, the second inlay video I would recommend is a Redneck's Guide to V-carve Inlays. And in this particular one, where he is doing multiple inlays and things, they're being done in sections because the glue up and all, right? And everything. So a Redneck's Guide to V-carve Inlays, I would definitely recommend that video by M&S Woodworks and Stefan Forcelli's, hopefully I pronounced his name right, Deep Inlay V-carves, that tutorial. I would highly recommend those two. And for sure. But the I let my inlays cure for a good few hours before I surface them off to do the next inlay if there's multiple to do. But to be fully, cured, it's going to take a few days. But I mean, 24 hours before it's workable, for sure, and everything. And there's not a whole lot of glue there. That's why we minimize the glue gap. We don't want a big puddle of glue sitting there. It's a very thin layer of glue. 1 millimeter layer of glue, is all it needs and all it takes and stuff. So, And Daniel, that's as far as alignment of glue, grain and all that, wood grain and everything. That's up to how you want your design to look, which way you want your grain to flow. You might want the grain to flow a certain way on the peacock's tail or whatever. That's up to you. You can turn that board any way you want to. It's not going to affect the inlay any. So if you look at the Redneck's Guide to V-carve Inlay, that video, when he does the sun behind the well, if you look at the board that he carves the mel out of and how he has the grain orientated so it looks like the sun, you can actually see the roundness of the sun. All the grain is kind of flowing in that direction from how he did his glue up. All the grain it creates that round textured kind of circle. His wingay and maple and all that. Yeah, grain direction is up to how you want it and everything and all. So to recap on this, you have your female, and in my case, if I was doing this inlay is exactly what I'm setting up here. My magic numbers are, my female pocket is 1/4 inch deep. Okay? My glue gap is 0.039. It's equivalent to about 1 millimeter. My clearance, 0.078, equivalent to about 2 millimeters. Those are my magic numbers: female pocket, glue gap, and clearance. What that leaves me is, if we do the math, my plunge, my contact here, the contact is the top of my female board, my project board, right? Minus the glue gap. So that's how much contact it is. So 0.25 minus 0.039, 0.211. Okay? Or 6.35 millimeters minus 1 millimeters equals 5.35 millimeters. However you want to look at it. Metric or inches, that's up to you. Now, so that gives me my contact. So my pocket depth, where my top of my board to the bottom of my female cut, that's my pocket depth, 0.25. My pocket depth, all right, minus my glue space is my contact. My contact, in this case, it's 0.21. My contact plus my clearance equals my plunge depth. My contact plus my clearance equals my plunge depth. Okay? So my pocket depth, which is the top of my board down to the bottom of my pocket. My contact is the top of my board down to where my piece fits in. My total contact, once it's fully inserted, minus the glue gap, in this case 0.211. And that contact area plus the clearance that I want to achieve, and I want to achieve 2 millimeters of clearance. That's the space when this thing is fully inserted into its inlay. When that mill is fully inserted, the clearance, the gap between the top of my board and the bottom of that mill part, that clearance, that space, that air space, I want 2 millimeters. I want 0.078 inches. So my contact plus that clearance is my total plunge. So 0.289 is my magic number when I'm creating my mill cuts. So whatever my start depth is, my flat depth, I need to end at 0.289. And I want a deep start depth and a shallow flat depth. So 0.211 to 0.078. 0.211 plus 0.078 equals 0.289, my magic number. But now that total depth is a lot to carve, so I'm going to break it up into passes by creating separate tool paths. And my two tool paths are going to, my first and my second tool path are going to equal up to that 0.211. In my case, it equaled 0.216. I overshot it a little bit, right? 0.216. So I just subtracted, I just made it, because I knew 0.211 is where I wanted to start. So I just subtracted that 0.005 from it to get it. Because I'm subtracting, or I'm adding 0.078. That's what I'm cutting to. And once again, this is the final time out, so I don't confuse you. First cut started a 1/16 of an inch down, 0.06, and it cut 0.078 more, 2 millimeters more from that start depth. Okay? So that material from Z0 down 0.06 plus that additional 0.078, that 0.138 inches of cut, and it's big, it's like a little over 1/8 of an inch, right? But that 1.38 inches of cut, that's my first cut. Then all that's been cut away. So when I start my next cut at 1.38 inches, I'm taking away another 2 millimeters, 0.078 from that. So 1.38 plus 0.078, that brings me to 0.216. Now, I want to take 0.078. That's my magic number. That's my 2 millimeters. I want to keep constant with that through these 3 tool paths, right? I want to keep constant with that. So on my final mill cut, that 0.078, that 2 millimeters I'm taking off, if I were to take 0.216 and take another 0.078, I would overshoot my total 289. 289 is the goal. 289 is the goal. From 0 to 289 is the goal. If I kept that 216 and I cut 0.078 from that, I'd overshoot it a little bit, so I got to subtract a little bit, and I made it 0.211. So that final cut started at 0.21, took another 0.078, and all 3 of those cuts added together equal my 0.289. 0.289. That's my full depth. From the top of this mill down to the top of the clearance area. Or the bottom of the cut, however you want to look at it. Okay? All right. Now, with that, ladies and gentlemen, that is how we do our V-carve inlay. And for our project, this was another long class. I was hoping it'd be a short one. But for our project, these are our vectors and everything. And we don't need this and don't need this here. Okay. We don't need this. There we go. All right, so that's our vectors and all. Now that leaves one last thing. That leaves creating the sheet for our legs and our little chopstick holder. And we're going to do that really quickly. We're going to create a new sheet. This sheet is going to be 1 inch thick. 1 inch thick. We can go with the 1 1/4, what have you, 1 1/4, but 1 inch. It's gonna go 1 inch because we gotta. Anyway, and this is gonna be our leg parts, and stick holder, whatever you want to call it. Okay. Now, on our let me get to the size of it. It needs to be at least 8 inches in length, at least at a minimum, because that's how long my legs are, right? So in this case, I'm going to go 8.5 inches wide. And I only need like 3 inches, 3.5 inches, whatever. 3.5. And the thickness, if I have any, it's got to be at least 1 inch thick. It's got to be at least 1 inch thick because of the legs. My legs are 1 inch wide. So it's got to at least be 1 inch thick. So there's that. Now I'll leave it at 1 inch. All right. Now, for me, this is going to be maple as well. And this, because of, its size and the parts that are being cut out of it and everything, I probably would end up making a couple of these trays and cutting the parts all out, kind of ganging them up, what I mean. But in this case, we're going to just be cutting 2 legs out of it and a holder just for this one part here. So we're going to take our 2 parts and we're going to move that over to that sheet here. And stand by while it gets the sheet loaded. I'm going to hit save just in case the pausing scares me every once in a while. Save early, save often, ladies and gentlemen. Save early, save often. Oh my gosh. Water's the fluid of life. Okay. We're going to take these parts and let's get them centered on the board. And all right, I need 2 of these legs, so let's move one up here, and let's hold the control key down and bring one down here. And like I said, I'd make this piece probably a little bit bigger or whatever, since if I was going to make a few of these, I'd gang them up, try to gang my parts up as much as possible, right? And everything. And all. If I knew I was going to make a few of these and I have all this waste here, I might, throw out a few of these type of things, just so I have it for the next one, that type of thing and all, if it stays consistent and everything. But for right now, we'll just stick with the parts that we have here. All right. Now, on here, we are going to use a 1/4 inch end mill to cut the parts out. And by doing that, I'm going to, right here, I'm going to get a bit of a radius. So I don't want an 1/8 inch radius. I want to minimize my radius, basically, is what I'm trying to say, on these 2 areas and everything, because I'm going to have to, break the edges on my part so they have a nicer fit kind of in those 2 little areas, those 2 little point areas and stuff. Now I have a 1 inch, I have a bit that has a 1 inch cutting height to it. and everything, an 1/8 inch end mill and all, that I could use, and that will get through, you know, this just fine. And or I could, you know, use my 1/4 inch end mill. I just have to be mindful that my edges, I just have to kind of do a little finessing, you know, before, when I put these things together and stuff. And as far as the assembly on these, on the legs, that's totally up to you. You can drill through the legs and, you know, countersink and put screws in. Stainless steel screws or something that's not going to rust or what have you. And then you can plug them. You can use dowels if you want. You can just glue it in because it's going to be recessed into that little recess. However you want to assemble the legs on there, that's fine, you know, and all. I'm going to glue because if I did my cuts just right, it's going to be a pretty good fit, right? So if I've done everything right, my drawings and all that stuff, it's going to be a pretty decent fit, and all. So I have to be mindful that when I, you know, come in and cut this, I'm going to end up with that radius here. So I'm going to have to radius my part, you know, my table and all, or my tray, you know, to get a nice, you know, fit there and everything. I'm going to use my 1/8 inch end mill to minimize that radius a little bit. So all I have to do is just kind of break the edges. I don't want to use a 1/4 inch end mill on this. So I'm going to take, and if you need a 1 inch end mill, the speed tool end mill, Build It TV, build. All right, are y'all still with me? Did I buffer? Because I'm losing internet a little bit. The chat got disconnected and now it's reconnected. So let me know if I lost you. I wasn't paying attention to if I was buffering or not. All right, and so that's my two parts, the two legs there, and they got their tabs on them and everything. So now this part here is going to be a profile cut. Now this part was sized exactly to the same size as my recess here as far as the length, but the thickness, this is only 3/8 of an inch thick, or a 1/2 inch. Now I got to go back and verify. Hold on a second. Let me stand by. It is 3/8 of an inch thick. So my material is 1 inch thick. So I got to pocket out some area to remove some area and everything before this gets cut. And I need to do a little bit of a kind of a, you know, overcut, so it's not such a tight fit, so it just, you know, sits in there, right? So the first thing I'm going to do here is I'm going to go ahead and just throw a rectangle up here, and I'm going to do a pocket cut. And I'll just keep the 1/8 inch end mill there. But I am, you know, 1 inch thick, and I want to leave 3/8. So 5/8 is, you know, I need to mill down, pocket down, and everything. So I'm going to pocket that down. And then my profile cut is going to cut that 1 inch deep, and my bit, if I was smart, was I smart? Let me see. If I was smart, I'd have made my pocket to where my bit could fit in there. My mouse is now deciding to be a pain in the butt. Okay, let's recalculate that pocket. Okay, now my part here is going to be a profile cut, but I've already pocketed out 5/8 of it, right? So I can start at 0.625 and cut the other 3/8 of an inch on the outside of the line, and I can add some tabs. I'll just make this tab about a 1/16 of an inch thick, and I'll throw a tab here and here. I don't need a lot of tabs for this. I'll just go on the sides. Okay, let me get rid of that one. All right, now I need, on this, I need to do an allowance, and it's a negative number I want to carve over the line. And I'm just going to go 0.002, 2 thousandths of an inch, because it's going to do it on both sides, so it's about 0.004. Let's go 0.0025, and that'll give me about 0.005, 5 thousandths of an inch of clearance, and that should give me a nice fit, nice friction fit and everything, where it's not too tight to get in and out. So it needs to be a negative number because it's going over the line. We're overcutting, so we're negative. We're taking that material away. All right, so let's calculate that. Okay, and if we preview those toolpaths, we have our first pocket toolpath that's going to come in and remove. All right, are we back yet? We should be back. All right, stand by. We should be back. Oh, this is where we're falling off. We're about to say goodbye anyway, so this is going to be our board, the top of our board alignment holes. And it's going to cut 3/8 of an inch, starting at 0, cutting down to 0.375. with a 1/4 inch end mill. And we're going to use pecking. Okay, for our alignment holes. Now, the alignment holes are going to get, we're going to move that up to the top of the list. We'll go through and, clean up all the tool paths and everything. I'll get them all cleaned up for you guys and girls. I'll provide this file for you. I'll clean it up in case one of you want to give it a shot and all. You're going to get the 2 koi and the peacock vectors as well. But we'll give this to you so you can, maybe you want to try to make it. If you do, let me know. I'll also include the links to those dishes and some chopsticks, or you can just look up chopsticks on Amazon. But anyway, so now on side 2, our wasteboard alignment holes, these are going to be a drilling tool path. They're going to cut, start at 0 and cut to 1/4 of an inch deep. Use pecking all, but this is going to be our waste board holes. So don't forget to zero out on the top of the wasteboard before you drill these holes. And when we, those will be the first thing that we drill, and then we stick our pegs in, we flip our project board over, and we start carving the back side, which are all the chamfers and everything. Okay, so now if we were to preview, let me get rid of really quickly, let me delete some toolpaths that don't belong in tonight's class. Stand by. Okay, so that belongs, all that, fluting. All right, this one doesn't belong. This one doesn't belong. This one doesn't belong. All right, so if we were to, we got our board alignment holes and then all of our tool paths on this side, flip it over. We have on side 2, we have our wasteboard holes. We have our chamfers there. The profile cut is fine. That'll cut it out. That chamfer and then our foot pockets. So let's preview all sides. Preview all sides. And this will be the final preview, right? This will be the final preview and everything. Now for me, my alignment holes have to be moved out just a little bit because of the 20-degree V-bit cutting. I'm using steel pins, and you'll see in just a second when after it flips over and all. But it cut into the alignment holes a little on that back side. But oh no, never mind. I'm an idiot. Sorry. That gets cut in the wasteboard. They aren't even there. Never mind. Ignore what I just said. All right, this is our final wrap here, and I don't know how much buffering and how much we lost towards the ends, guys and girls, basically, let this. I'm going to click on this waist and this waist.
Sorry, I'm not sure.
Alexa, stop. All right, so imagine, if you will, here's our board. Right? And we have a nice little inlay in there. And we have that wasabi, the chopstick holder that'll be sitting in there as well. Nice contrast colors. On the bottom side, we'd have our legs that wrap up around, and they stick out, a 1/4 inch on the edges and everything to give us a nice, look all the way around. But it'd be a nice looking piece. And I will clean everything up, get all the toolpaths named. I'll create vectors, vector files, DXF and SVG for those of you guys and girls who do not have version 11.5 of the Vectric software, and you have to import the vectors. I will, since this one has got a lot going on, I'll try to include a PDF with it. So if that's going to be the case, if I'm going to provide this with a PDF and all, you're going to have to give me a day or so before the files will be available for download. So I will work on that and get it all laid out. The inlay, the leg pieces, and all of that. So we have our sheet, our main board is going to be the, this here. And then our leg parts. Wait for it. Wait for it. The leg parts will be cut out on the other side. So the two sets of legs, the only thing again, we'll have the radius of the bit. So whatever bit you use to cut out your parts, just remember those chamfers that were on the main tray, you're going to have to work the edges a little bit to round them up a little bit so they fit into your parts nicely and everything. But we'll have our those two legs that'll fit in there. And again, how you want to attach the legs, you can glue them in. You can glue and screw. You can dowel them in. That's totally up to you and everything. So we have our pocket cut that's going to take out some of the meat. And then our part gets cut out of that. Right? So that'll be those three parts. And then we have our male inlay. Right? The male inlay. Now, for your inspiration, do not, make it your own, make it your own kind of thing. But for your inspiration, the, let me see here. For the party type tray, just imagine, a couple of places for sauce. A couple of places, that's on that board that's, 20 by 9 1/4, right? 20 by 9 1/4. A couple of places for maybe, two of those sauce trays. A couple of little recesses for your wasabi and your ginger strips and stuff. Pockets, individual pockets for the 4 sets of chopsticks because the party tray is going to feed up to 4, right? Type of thing. So think about that, lay out a design that matches that and everything. You can use for your inspiration. All I did was type in wood sushi trays, right? And there's all these examples. For the party for 2, right? The party for 2 and all. You can, again, whatever you want. I like the little, I like making an area for the bowl, for my sushi trays. And, I like those recesses and all. But they don't have to have them kind of thing. And not everything has to be that way, right? It can be however you want. But for the sushi for 2, imagine, right? Keep in mind, you've got 2 people eating, so maybe 2 places for the sauce. Make them convenient, like the sauce is down by them, so they're not reaching over, trying to dip in, someone else's sauce or whatever the case may be, right? Because you might like Dutch sauce, they might like soy sauce. You might like this, they might like that, right? Kind of thing, whatever. But a couple of places for the chopsticks. Now, I like the chopsticks rest. I like the removable ones. So think about 2, right? 2 of those where they can set the chopsticks off the board or on the board. These are just in this particular design. If we were to zoom in, all they did was create kind of a little pocket, a little chamfer, and it's shallower on this end, deeper on this end. So it's kind of a flute, same kind of fluting situation, right? They did that little fluting, so it's deeper on this end because the chopsticks are tapered, right? So use this for inspiration. Use these images. I mean, there's tons and dozens of images and things and all. There's all types of designs and shapes and everything. And if you look closely, we'll zoom into this one. They pouring the sauce right on the board, right? You got to finish on it and all that stuff and everything. Food safe finishes, guys. Butcher block oil or, something like that. But anyway, they just pouring the sauce right into the wood on this one, right? So, but there's different designs. It doesn't have to be just square. It could be round. It could be whatever, right? There is all kinds of cool, creative designs. Again, Here's one where, again, where they have the little separate tray that, you know, comes out to hold the chopsticks and stuff. And this one, they even made a wooden bowl. They carved their own wooden bowl for the sauce. There you go, right? We didn't even think about that avenue or anything like that. So I'm going to provide the files of what we created tonight for you guys and girls to kind of give you a starter and all. But think about all the different options. You type in, I typed in wood sushi platters or wood sushi trays. Either one of the two work. And get you some inspiration, right? And these could be scrap wood projects, low cost, high yield. I mean, if you saw some of them, I mean, they were in the 200s. And if people like sushi, they'll spend the money. And then if you make good enough ones or nice enough ones, right? Think about hitting up your local sushi restaurants and see if they would like some custom trays made with their logos engraved in them and things like that you could sell to them, that they could use in their restaurant. Right? All right. All right, everybody. With that being said, it's a late night. I was hoping this would be a short class, but evidently there was a lot of elements to it. And with the buffering and all, it didn't help. Y'all have a wonderful night. Thank you all to my super chatters. I really, really greatly appreciate each and every one of you. And Big Daddy Fish, Bruce DeGarmo, appreciate you all. Thank you very much for that, that super chat and everything. Y'all have a great night. Until next time, we'll see you soon.